Hello viewers, in my previous video I have explained up to question number 10 of 9a, and in this session I am going to start from question number 11. Here the question is, a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height 5 meters. From a point on the plane, the angles of elevation of the bottom and the top of the flagstaff are 30 degree and 60 degree. Find the height of the tower. As given in the question, a vertical tower stands on a horizontal plane. Let this be the horizontal plane and this is the vertical tower. The question is given, a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff. Suppose this is the flagstaff. Okay, this part is the flagstaff. This part is the tower and this is the horizontal level. It is given that a vertical flagstaff of height 5 meters, that means from this part up to this much, this height is 5 meters. From a point on the plane, this is the plane, from a point on the plane, the angles of elevation of the bottom and top, this is the bottom, this is the top. So if I join this part and this part, this is the bottom of the flagstaff and this is the top of the flagstaff. It is given that the angle of elevation are 30 degree and 60 degree. So this angle will be 30 and this angle will be 60 degree. We are to find the height of the tower. That means this height from this point to this point, this height is to be calculated. I hope question is clear. This is the tower and this is a flagstaff on top of it. From a point, this is the observation point, the angle of elevation of the bottom of the flagstaff is 30 degree and the angle of elevation of the top of the flagstaff is 60 degree. We are to find the height of the tower. We can name this one as suppose A, this point as B, this point as C and this point as D. Let BC, because here we have considered BC to be the tower, so we have to let BC be the tower, AB be the flagstaff, on top of it, and here D is the observation point, so we have to mention this one, and D be the observation, I am writing in short, observation point. Okay, first part is clear. Now here BC we don't know, so we can consider let BC be H meter. We can consider this one to be H, this part. AB is how much? AB equals to 5 meter and CD is not given. Angle BDC equals to 30 degrees and angle ADC equals to 60 degree. Now in this question we have to find the height of the tower, that is this height BC is to be calculated. So we can write here to find height of the tower, and height of the tower is BC, so we can write height of the tower, that is BC. Now in this sum is little bit different from the previous sum, because in the previous sums you have seen only one triangle was there and here two triangles. Whenever this type of sums are there, always try to find the common element between the triangles. This triangle, if I consider BCD and triangle ACD, in these two triangles common part is CD. So from the first triangle we'll try to calculate CD and we'll try to place the value of CD in the next one, then it will be easier. Okay, so we are starting from the smaller triangle, that is BCD. So in the solution part we can write, in right triangle BCD tan of 30 Now why I am considering 10, I think you know now, because in this triangle this height is to be calculated and this base is the common part. So we want to relate this part and this part, that's why we are using tan 30. We know tan theta is the ratio between perpendicular and base. It will be CD. So tan 30 will be BC by CD. Value of tan 30 is 1 by root 3 equals to BC by CD. BC also we don't know, CD also don't know, let it be like this. So CD will be, if I cross multiply, CD will be root 3 BC, and since we have considered BC to be H, we can write root 3 H. Let it be equation number 1. Okay, that means from the smaller triangle what we have done, we have calculated the value of CD. Now we are going to place this value in the bigger triangle. In right triangle ACD tan 60, here also we have to relate perpendicular and base. So here we have to consider AC and CD. AC and CD, these two if I want to relate, because AC is the perpendicular and DC is the base. So tan 60 will be AC by CD. Tan 60 will be AC by CD. What's the value of tan 60? It is root 3. AC, if you see the figure, AC will be AB plus BC. So AB is 5 and this part is H. So we can write AB plus BC initially. So and instead of CD, CD is root 3H. So we are just replacing the value of CD by root 3H. Here you write using 1. Now root 3 into root 3, 3H equals to AB plus CB. AB is 5 and CB is H. So we can write 5 plus H divided by 1, so no need to write. So 3H minus H, 3H minus H equals to 5. 3H minus H, it will be twice H equals to 5. That means H equals to 5 by 2. If I divide, I am going to get 2.5 meter. Okay, therefore the height of the tower, therefore we can write therefore height of the tower equals to how much? 2.5 meter. That's our answer. In question number 12 it is given a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff. At a point on the plane 30 meters away from the tower, an observer notices that the angles of elevation of the top and bottom of the flagstaff are 60 degree and 45 degree respectively. Find the height of the flagstaff and that of the tower. Now let me first draw the figure. As given in the question, a vertical tower stands on a horizontal plane. Suppose this is the tower and this is the horizontal plane and is surmounted by a vertical flagstaff. So this part is the flagstaff. Clear? This is the flagstaff, this is the tower, this is the plane. At a point on the plane 30 meters away from the tower, at a point on the plane 30 meters, suppose this distance is 30 meters away from the tower, an observer notices this is the point from where observer is observing. An observer notices that the angles of elevation of the top, angle of elevation of the top and bottom of the flagstaff are 60. Top one is 60 and for bottom it is 45 degree. Find the height of the flagstaff. That means we have to find this point to this point. Let me name this one as A, this point as B, this point as C and this point as D. Let here BC is the tower, so we can let BC be the tower and AB is the flagstaff, so we can write here and AB be the flagstaff. Be the flagstaff on top of it. On top of it. Okay, and this point is the observation point, so we have to mention and D be the observation point. AB be X, we can consider this part to be X, BC to be BC, be 8. DC already you know, DC equals to 30 meter. Okay, angle BDC equals to BDC, this is 45 degrees, and angle ADC equals to 60 degrees. We are to find the height of the flagstaff and that of the tower. So we have to find height of the tower, that is BC, and height of flagstaff, that is AB. Clear? We have to find two things. One is the height of the tower, and then we have to find the height of the flagstaff. Now out of these two triangles, the smaller triangle is BCD. Always it is better to start from the smaller triangle. In the solution part we can write, in right triangle BCD, here we have to delete perpendicular and base. We have to use tan theta. So here we are writing tan of 45 degrees equals to BC by CD. We know tan 45 value is 1. BC we don't know. We have considered this one to be H by CD. CD is 30. So H equals to 30. So first part we got the height of the tower is 30 meters. Now in the bigger triangle, that is ACD, in right triangle ACD, tan of 60 degrees, tan 60 will be AC by CD, tan 60 value is √3 is known to us. What is AC? AC here is AB plus BC, that is x plus h. So x plus h. We know CD equals to 30. So instead of CD we are writing 30. So 30 √3 equals to x. H is 30. So 30 √3 minus 30 equals to x. If I take 30 common, I am left with √3 minus 1 equals to x. Therefore x equals to 30, within bracket value of √3 is 1.732 minus 1. So x equals to 30 into, if I subtract, I am going to get 0.732. On multiplying these two, I am going to get 21.96. Therefore x equals to 21.96 meter. Therefore height of the tower, we got height of the tower to be 30 meter, h equal to 30 meters, and height of the flagstaff equals to 21.96 meters, and that's our answer. I hope this one is clear. In question number 13, it is given that a tower is 50 meter high, its shadow is x meters shorter when the sun's altitude is 45 degree than when it is 30 degree. Find the value of x. Let me now explain the figure, and in this sum it is given √3 equals to 1.73. In question number 13 it is given a tower is 50 meter high. Suppose this is a tower which is 50 meter high. Okay. Its shadow is x meter shorter when sun's altitude is 45 degree than when it is 30 degree. Find the value of x, and value of √3 is also given. Forget about 45 degree. Whenever it is 30 degree, then suppose this is the length of the shadow and altitude of the sun, this angle is 30 degree. Clear? When altitude of sun is 30 degree, this is the shadow and this is the tower. Now whenever it is 45 degree, it will be shorter. Now suppose this angle is 45 degree, this is the length of the shadow, and it is given x meter shorter. That means from this up to this much, this is x meter. Clear? Let me name this one as A, this point as B, this point is C, and this point is D. I hope this one is clear. This is the tower. BD is the shadow when altitude of sun is 30 degree. BC is the shadow when the altitude of sun is 45 degree, and CD is x meter. Now let me do the sum. Let AB be the tower and BC, BD be the length of shadows when altitude of sun is 45 degree and 30 degree respectively. Okay, so here AB equals to 50 meter, this part is 50, CD equals to x meter, it is given in the question. Angle ACB equals to 45 degrees and angle ADB equals to 30 degrees. What we have to find? We have to find this length, that is CD. So we can write here to find CD, that is x. Whenever this type of sums are there, always it is better to start from the smaller triangle. Here from the smaller triangle we will try to calculate BC, and once BC is known, we can place this value in the bigger triangle to find the value of x. Okay, so in the triangle ABC, so in the solution part we can write in right triangle ABC, since we have to relate perpendicular and base, we have to use tan. So tan of 45 degree will be AB by BC. Tan 45 is 1 equals to AB. AB will be 50 by BC. So if I cross multiply, I am going to get BC equals to 50 meter. Let it be equation number 1. Okay, first part is clear. Now we are going to take the bigger triangle, that is ABD. In right triangle ABD, in right triangle ABD, this triangle ABD, here also perpendicular and base, so we have to use tan. So here tan 30 will be, we know tan theta relates perpendicular and base, that is AB by BD, AB by BD. Tan 30, we know value of tan 30 is 1 by root 3. AB is how much? Now if you see the figure, AB equals to 50, and from the first part we got this is also 50. So instead of AB we can write here 50. Instead of BD we can write BC plus CD, BC plus CD. So 1 by root 3 equals to 50 by, what is BC? BC we got from the first part, BC is 50 and this part is x. So BD can be written as 50 plus x. So it will be 50 plus x. If I cross multiply, 50 plus x equals to 50 root 3. So x equals to 50 root 3 minus 50. If I take 50 common, I am going to get root 3 minus 1. Value of root 3 is given in the question 1.73 minus 1. Now 50 into 0.73, and if I multiply, I am going to get 36.5 meter. Okay, 36.5 meter. Therefore x equals to 36.5. Therefore required value of x is, required value of x equals to 36.5 meter, and that's your answer. So I hope this one is clear. Now I'll do the next one, that is question number 14. In question number 14, it is given that the angle of elevation of the top of a tower from a point A on the ground is 30 degree. On moving a distance of 20 meters towards the foot of the tower to a point B, the angle of elevation increases to 60 degree. Find the height of the tower and the distance of the tower from the point A. Let me now draw the figure. Suppose this is the tower and this is point A. and this is the horizontal level. Okay, it is given that the angle of elevation of the top of a tower from a point A on the ground is 30 degree. That means if I join this point and this point, then this angle is 30 degree. This is the tower. Okay, again it is given, on moving a distance of 20 meters towards the foot of the tower from point A, if I move a distance of 20 meter, suppose this one is 20 meter, this point is B, as given in the question, on moving a distance of 20 meters towards the foot of the tower to a point B, the angle of elevation increases to 60 degree. That means if I join this point and this point, then this angle will be 60 degrees. Find the height of the tower and the distance of the tower from point A. So we have to calculate this height and A to this point. Let me name this one as C and this one as D. So we have to calculate AC and DC, because it is given in the question, find the height of the tower and the distance of the tower from the point A. So DC and AC we are going to calculate. Let DC be a tower and A, B be the observation points. Okay, as given in the question, this is the tower and these two are the observation points. Here it is given AB equals to 20 meters. Angle DBC equals to 60 degree and angle DAC equals to 30 degree. So to find number 1, height of the tower, and height of the tower is DC, and distance of A from the foot, that is AC, distance of A from C, that is AC, we have to calculate. Clear? Now I told you in the previous sums also, whenever this type of sums are there, always start from the smaller triangle and try to find the common part. In the smaller triangle and in the bigger triangle, common part is DC. So from the smaller part we can calculate DC and we can replace it in the bigger triangle. Let me show how to do. In right triangle DCB, because here smaller triangle is DCB and we want a relation between perpendicular and base, so I am going to use tan 60. Tan 60 will be DC by BC. Now what's the value of tan 60? Tan 60 is √3 equals to DC by BC. So from here if I cross multiply, I will get DC equals to BC √3. Let it be equation number 1. So that means from the smaller triangle we have calculated DC, and now in the bigger triangle DCA I am going to replace the value of DC by BC √3. In right triangle DCA, tan of 30 degrees equals to DC by AC. Since here perpendicular and base, these two are needed, so I am using tan theta. So tan 30 will be DC by AC. Okay, now tan 30's value is 1 by √3. DC we don't know, but here already we have calculated DC is BC √3, so we are writing BC √3, and instead of AC I can write AB plus BC. Clear? Now if I cross multiply BC √3 into √3, it will be 3BC. So 3BC equals to AB plus BC. Now AB already we know it is given 20 meters. So we can write thrice BC minus BC equals to, instead of AB I can write 20. So this part is 20. So twice BC equals to 20. That means BC equals to 20 by 2. That means 10. Therefore, BC equals to 10 meters. Now, once we know the value of BC, it can be placed here to get the value of DC. So, we can write from 1, DC equals to BC root 3. And BC is 10. So, it will be 10 root over 3. And root over 3's value is 1.73. So, if I multiply, I am going to get 17.3. Okay, so we got DC and we got BC. Two things we have to calculate. One is DC, another is AC. DC we got 17.3. Now how to calculate AC? AC will be AB plus BC. So AC equals to, we can write AC equals to AB plus BC. And here AB already it is given 20 and BC we got 10. So 20 plus 10, 30 meters. Okay, therefore height of tower equals to DC we got 17.3 meters, and distance of A from C, that is AC, will be 30 meters, and that is the required answer. I hope this one is clear. Let me do the next one, that is question number 15. In question number 15, it is given the angle of elevation of the top of a tree from a point A on the ground is 60 degree. On walking 20 meters away from its base to a point B, the angle of elevation changes to 30 degree. Find the height of the tree. Let me first draw the figure now. As given in the question, the angle of elevation of the top of a tree from a point A on the ground is 60 degree. Suppose this is the point A on the ground, and from point A, the top of the tree, here angle is 60 degrees. So this angle is 60. Next line is on walking 20 meters away from its base. Now from here we are walking this way 20 meters. So suppose this distance is 20 meters. On walking 20 meters away from its base to a point B, the angle of elevation changes to 30 degree. Now the angle of elevation is, this angle is 30 degrees. Find the height of the tree. Suppose this part is, we can say C, this part is D. We have to find the height of the tree, that is DC is to be calculated. So here we can write, let DC be a tree and A and B be the observation points. Be the observation points. Clear? Here AB equals to 20 meter. Angle CAD equals to 60 degree. Angle CBD equals to 30 degree. What we have to find? We have to find the height of the tree. That means to find, it is DC, we can write height of the tree. Height of the tree. Okay. Now in the solution part, we can always start from the smaller triangle. Here smaller triangle is ADC, and here also perpendicular and base. These two are, I have to delete. So I have to use tan theta. So in right triangle ADC, because this angle is 90 degree, we can write tan 60 equals to DC by AD. We know tan 60's value is root 3 equals to DC by AD. So DC equals to AD root over 3. Let it be equation number 1. In right triangle BDC, tan 30 will be CD by BD. Okay, here tan 30 will be CD by BD. Now tan 30's value is 1 by root 3. So from equation 1 we can write CD equals to AD root 3, and instead of BD I can write AB plus AD, because BD is AB plus AD. So I can write AB plus AD. Okay, now 1 by root 3 AD root 3, and AB we know it is 20, so I can write 20 plus AD. Okay, So if I cross multiply, 20 plus AD equals to root 3 into root 3, 3AD. So 20 equals to 3AD minus AD, it will be 2AD. So 20 equals to 3AD minus AD, 2AD. So AD equals to 20 divided by 2, 20 by 2, that is 10 meters. So we got AD. Now we have to calculate DC. From equation 1, we know DC is AD root 3. So we can write from 1, DC equals to AD root 3. AD is 10. Root 3 is 1.73. So if I multiply, I am going to get 17.3 meters. Therefore, height of the tree equals to 17.3 meters. And that's the required answer. In question number 16, it is given, from the top of a building 15 meter high, the angles of elevation of the top of a tower is found to be 30 degree. From the bottom of the same building, the angle of elevation of the top of the tower is found to be 60 degree. Find the height of the tower and the distance between the tower and the building, and here it is given root 3 is 1.73. Let me first draw the figure because this figure will be a little bit complicated. Suppose this is a building, and in the question it is given from the top of a building 15 meter high, that means height of this building is 15 meter, and from the top of the building the angle of elevation of the top of a tower, from this point if you see the tower, it is given angle of elevation, that means tower must be taller than the building, and from this point when you see the top of the tower, angle of elevation is found to be 30 degree. So this angle is 30 degree and this one is the tower. Clear? As given in the question, from the top of a building which is 15 meter high, the angle of elevation of the top of the tower is found to be 30 degree. So this is the tower, this is the building, and from the top of the building you are viewing the top of the tower and angle is 30 degree. Now it is given from the bottom of the same building, from this point if you view, the angle of elevation of the top of the tower is found to be 60 degree. That means from this point when I am joining this point, then this angle will be 60 degrees. This height and this distance, these two things I have to calculate. Let me name this one as, suppose this one is A, this one is B, this one is C, D, E. I hope figure is clear. Let me now do the sum. Let AC be a tower and ED be the building. ED equal to 15 meter given. Angle AEB equals to 30 degrees. Angle ADC equals to 60 degree. To find first is height of the tower, and as I have drawn, tower is AC, that means we have to calculate AC first, and second thing that I have to calculate is the distance between the tower and the building. Distance between the tower and the building is DC, so distance between tower and the building, that is DC. In the solution part we can write here ED and BC both are equal. As you can see here, ED and BC are equal. Since this is 15, this part also will be 15. So I can write here ED equal to BC equal to 15 meters. Now let me start with a smaller triangle. Here also I have to relate perpendicular and base. So I am using tan theta. So in right triangle ABE, tan 30 will be AB by BE. We know tan 30 is 1 by root 3. So 1 by root 3 equals to AB by BE. So if I cross multiply, I am going to get EB equals to root 3 AB, Let it be equation number 1. Now I am going to consider the bigger triangle, that is ACD. In right triangle ACD, tan of 60 will be, tan 60 will be here AC by CD. It will be AC by CD. Tan 60's value is √3. And AC is nothing but AB plus BC. We can write here AB plus BC. And instead of CD, we can write BE because these two are same. So instead of CD, I am writing BE here. Okay. Now √3. AB, we don't know. BC is how much? Because already I have written here BC equals to ED equals to 15. Because if this part is 15, this part also will be 15. From this part up to this much, this is 15 meter. So I am writing instead of BC 15. And we know EB equal to √3 AB. I am writing here √3 AB. You can write using 1. Okay, if I cross multiply, it will be √3 into √3, 3AB equals to AB plus 15. This AB, if I transfer in the other side, it will be twice AB equals to 15. So AB equals to 15 by 2. That will be 7.5 meters. Okay, so we got AB. Now we have to calculate the height of the tower. Height of the tower is AC. So AC equals to AB plus BC. AB we got 7.5 and BC is 15. That will give me 22.5 meter. Okay, here we got this one is 15. 15 means 15.0. 7.5. If I add, I will get 5 to 22.5. Clear? And second thing that we need is DC, distance between the tower and the building. And here we got DC and EB same. So we can write DC equals to EB. And EB equals to, if you see the first equation, it is √3 AB. √3 into AB. AB how much we got? 7.5. So 1.73 into 7.5. If I multiply, I am going to get around 12.975. And 12.975, if I round off, it will be 12.98 meters. Therefore, we can write the final answer. Therefore, the height of the tower, height of the tower, that is AC. AC how much we got? 15 plus 7.5, because this one we got 7.5, that will be 22.5. Here also we have calculated AC is 22.5. And what is the distance of tower from building? Distance of tower from building is 12.98 meters. So these are the required answers. I hope this one is clear. Always whenever this type of questions are there, first of all try to draw the figure correctly, because this is the most important part. If figure is correct, then only your sum will be correct. And that's all for today. In the next video I am going to show question number 17 onwards. Till then, bye bye, take care and wait for the next part.